Hello, I'm Andy at Line2Line Coatings. At Line2LineCoatings.com you can find some videos that explain abradable powder coatings and how they work. APC basically refines the geometry of each piston in an engine to reduce its friction and improve its sealing. To understand these benefits on a piston, we need to look back at the Strybeck relationship and secondary motions on the pistons and rings. These two factors explain why racers report superior performance and durability in APC engines compared to otherwise identical builds. Pistons are manufactured with incredible alloys, designs, and accuracy. The problem is the cylinder bores are almost never straight during operation. There are all kinds of distortions from assembly, temperature gradients, and operational loads. Abradable powder coatings safely take up the last bit of clearance on your pistons. So after break-in, each piston fits ideally in its own bore. The improved fit reduces secondary motions like rock and slap from the pistons and rings. Holding the rings more stable, of course, means better sealing for power and less wear. So for example, on an 8-cylinder engine, one cylinder may be cold and another may be hot, and they're all a little bit twisted. All of the pistons have to be designed the same so that none of them will scuff or seize in the smallest, most distorted hole. Therefore, by default, excess clearances are designed into most of the cylinders. This transparency illustrates a bore, which is nice and round. Now we have another transparency, which is the piston. So if the piston moves to the side after the crossover, you can see that a very narrow area actually touches, and that area is carrying all the side load. Out here in the green area, if you recall from the Strybeck equation, let's say that's the edges of your skirt, this area is stirring a lot of extra oil and not carrying any load. So this is actually increasing the friction. And then we do have a narrow area of transition, which on the Strybeck is yellow, representing the lowest friction. So now let's see what happens if we put APC on the skirt. So the red on here is the APC coating, nice fuzzy coating. Notice when we center it in the bore, there's no gap, and in fact there's interference. So that's where the abrasion process will occur. So if we look at the coating after the abrasion, notice it's thicker over on the sides, thinner in the middle, and we've got a very thin oil film represented by the yellow and low friction all the way across the skirt. Let's look at a more realistic bore, which is not quite perfectly round. We put our round piston in there, and look, the fit's much worse. And that's all the gap that's required to keep anything from scuffing. APC can make it fit even in this kind of condition. So let's look at the motion of the piston in the bore. These are transparencies. So the pistons have a barrel shape to them, so when they come up and down, they can transfer smoothly from side to side in the bore. However, all that rocking causes your rings to expand and contract, and that's a bad thing. So with the APC, what we want to do, again, is fill all this in and quickly put it into the bore and have a bunch of that barrel effect go away. But it's safe. It's safe. It's a safe shape. It just takes away a little bit of barrel shape. And now the piston can run truer. It doesn't have the secondary motions of rocking. Also, notice we've got more area touching, so the oil film is not carrying as high of a unit loading. This makes a big difference. Notice also that now that my piston can't rock as much, I don't need to leave as big of a gap up here at the crown because it can't hit. It's not moving as much. So all these little benefits add up to a smidge of power and a lot more durability in your power cylinder. Here's how APC works. There's no change required to the metal dimensions. We just build up a thick, fuzzy coating and you build the engine tight, often a line-to-line fit. When you start the engine, the pistons expand and get even tighter, but that fuzzy coating quickly wears in to match the shape of the bore. When there's room for the ideal oil film to exist, the wear of the APC stops and the ideal shape of the piston is locked in. Jason Farrell is a top-running AMA rider. These are acceleration curves from two of Jason's engines, which were built the same year and raced on the same track. The blue ones are stock and the red ones are APC engines. Notice the dramatic improvement in acceleration and the higher peak power with the APC engine. 15% faster time to shift. Now let's look at RPM based curves, which are more standard, where you have RPM on the bottom. Jason's engine redlines at about 15,000 RPMs. Again, the blue lines are the stock OEM coating, and the dashed lines are the new build. The solid lines are after hundreds of miles of racing. Notice the APC engine, the red dashed line, is a little bit low on power when it's newly built. That's because there's a little extra friction as the pistons wear the coating in tight spots. After it's fully broken in, look at the power. Across the whole RPM range, there's added power. We see the same effect on a two-stroke. This is a TZ250 built by BCL Motorsports in Ontario, Canada. He did very careful A/B studies on it and determined that there was a smidge more power in his setup as well. In this case, it took 9 dyno pulls to exceed the baseline power. Let's go back to Jason's example. Every July at about 2,500 miles of racing, he tears his engines down, puts in new rings, pistons, wrist pins, and rod bearings, freshens it up. So this is the appearance of two engines that were on the same track for the same season, and you can see there's a little halo and some scratches showing the contact pattern on the stock skirt. This little halo on the top crown is actually worn because of the piston rocking. Notice the APC piston, we had full oil film coverage across the entire skirt, and there's much less evidence of rocking here. So let's look at his bearings after 2,500 miles of racing. Here's the typical failure mode. You've got a little wear spot and some drag marks. Notice the APC piston, without the shock of slap and piston rock, has the similar failure mode starting, but there's no drag marks. We've dramatically delayed this failure mode in his engine. The wrist pins also looked really good. So for the first time, Jason built his entire engine with the same parts for the second half of his season. Jason went on to ride 4,000 miles on that engine until it threw a rod when he missed one shift too many. But we were able to measure 3 out of his 4 cylinders for clearance. And here's what we found. They were all in between 7 to 9 10,000ths of an inch cold clearance. Remember, the stock minimum cold clearance was 18 tenths. So we took over half the clearance out of this high performance engine. That's why it lasted so long. We've had so much good feedback from different racers in 2-strokes, 4-strokes, vintage, new, circle track drag race that we know APC it makes engines better. There's 2 mechanisms it helps by. One is it makes a better oil film, a lower friction and more stable oil film on your piston skirts. The second is it safely reduces the clearances on your skirt, taking out secondary motions and settling the rings down to create a better seal and less vibration, which is destructive and parasitic inside your engine. So what we'd like to do is invite you to try it in your own equipment and let us know your feedback. Thanks a lot for watching. We've got some more videos at Line2Line Coatings.com.